Alright, good morning, algebra. This is going to be the first video of 3 going over our notes. Like I said in the welcome video or the intro to the week, there's a lot of properties this week that we're going to have to cover, so I'm going to try to keep the videos shorter by only going over 2 or 3 properties at a time. This one will be the longest as I am going over 3. So these are the 3 properties we're going to go over. Product of a power property, quotient of a power property, and power of a power property. Okay? All of these you can find in your workbook on page 171. I'm going to go over the algebraic definitions, meaning I'm not going to write like the word explanation down. You can go in your workbook and read those if you want to. I have always found those more confusing than just seeing the algebra. So we're going to talk about these, and then I have, I think, 9 examples. I know it's a lot, but with these properties, examples are going to be our friends, okay? So before we go into these, a couple things we have to remember. Here's our base, here's our exponent or power, and this is not 4 times 3, it's 4 times 4 times 4, okay? So keep that in mind when we're going through these. Most of these you've probably seen before, we've worked with before, but we haven't put formal definitions to it. So that is our plan for this week. Okay, so the product of a power property. The key with this one is the bases need to be the same. So in order to apply this, things have to have the same base. So if I have a base raised to a power times that same base raised to another power, the shortcut version is I can keep the base, and what I do is I add the powers. Okay? And you'll see a lot more when we go over examples, but that's what we do. Multiplying things that are the same base, you keep the base, add the powers. Okay? The quotient of power property, again, this is another one with the same base. The key is that base cannot be 0. Okay, so a cannot be 0, and the reason is a is in the bottom. Whenever you have a number in the denominator, it cannot be 0, otherwise it is undefined. Okay, so if we have a base raised to a power divided by that same base raised to a different power, we keep the base just like the first property, but instead of adding, we are going to take the top power and subtract the bottom power. Okay. I think of this also a different way, but it'll make more sense when we get to examples. Basically what I do is I say, if they're the same base, where are there more of them? Meaning which power has more? Does the top power higher or the bottom power? And that kind of helps me figure out where my answer needs to go. But that'll make more sense when we get to examples. Our last power we are going to talk about is the power of a power property. Okay, and I think of it as an extension of the product. So of the first one, that's the way I think about it. If we have a base raised to a power raised again to another power, the shortcut is you keep the base and you multiply the powers. Okay, and the reason I think of it as an extension of the product is because if I'm looking at this, I can say a to the m times a to the m times a to the m times a to the m. I can rewrite that n times. And if it's written like this, this is the same as the first property, the product of powers property. So that's why I think of this as an extension of that first one, because we could just write this out so it looks like the first one. But if you don't want to do that, especially if these are bigger numbers, the shortcut is you just multiply those powers. Okay? Getting to examples. Okay, so these examples, by themselves, these properties are very simple. When they get challenging is when you start applying multiple properties. Okay, so kind of in 6 a little bit. When we get to our other properties, you'll see that as well. So I'm going to kind of do these in groups of 3. So if you want to pause the video now and try the first 3, you will see the answers in 3, 2, 1. Here are the answers to the first 3. So x to the 12th times x to the 11th. The base is the same, so we add those exponents and we get x to the 23rd. Even though there's multiple bases, we can still apply it because we have two bases that are the same. Since there are no other numbers, the 3 does not change. Since there are no other bases that are x, that does not change. But we have a y to the 4th times a y to the 8th. Keep the base, add the exponents, we get y to the 12th. And number 3, now we look at common bases. A note here, all numbers are common bases. So if you have a problem like this, you always just multiply the numbers. Or if it happens to be like a fraction down here or a quotient, you always divide or simplify the numbers. So negative 8 times 4 is negative 32. My common bases are now x to the 4th, x to the negative 2. We add those things and we get x squared. And then y to the 3rd times y to the 6th. Add the 3 and the 6, we get y to the 9th. Okay? That's mostly focusing on the product of a power property. 4, 5, and 6 are working with that quotient, that second property, so the answers for those will be here in 3, 2, 1. Here are the answers for the next one. So, here are quotients. Remember when we have a quotient, we take the top power and we subtract the bottom. So because the bases are the same, 12 minus 8 is 4, so it's y to the 4th. Jumping here, remember with numbers, just simplify them. So 48 and 36 are both divisible by 12, becomes a 4 and a 3. Now top power minus bottom power, 2 minus 8 is negative 6. Okay, we haven't talked about this property yet, but we don't want negative numbers. And here's, like I said before, how I think about it. Where are there more x's, top or bottom? There's clearly more on the bottom, and then we say how many more on the bottom? Well, there are 6 extra on the bottom, so your final answer should have 6 extra x's, or x to the 6th, on the bottom. Okay, so that's how I figured, or that's how I kind of think of those problems. And that's what this negative will do. This negative 6 will move it to the bottom and become a positive 6, but we'll get to that later. Okay, 8 and 14 becomes 4 and 7. Negative 2 minus a negative 9, so negative 2 plus 9 is 7, so it's x to the 7th. And then 12 minus 3 is 9, y to the 9th. That would be number 6. Okay, go ahead and look at 7, 8, and 9. These are the property, the power of a power property. Okay, the answers will be in 3, 2, alright, 1. I know number 9 was a little different. We'll get to that. Okay, number 7. A power raised to a power. What you do is you keep the base and you multiply those powers. So 3 times 8 is 24. Number 8. Negative 3 times negative 2 is a positive 6. Number 9 I put on here is because sometimes when we throw in these negatives, that's where things get mixed up. You have to think of these as two different bases, because there's no parentheses. This negative is like a negative 1, and the 4 is obviously just a 4. So you have to think of them as different bases. So what is being raised to the 3rd power? Just the 4. Okay, so that's how we get negative 64. Sometimes that really confuses students, okay? So these are our first 3 properties. Remember, really take the time and do the practicing, ask some questions, come to our Google Hangout, make sure you watch the other 2 videos for the last 4 properties. Otherwise, I will talk to you later.